thank you very much, everybody. I'm going to formally start now. Okay, so we'll start with an acknowledgement of traditional owners. QUT, where we stand here, acknowledges the Turrbal and Yagara as the first nations owners of the lands where QUT now stands. We pay our respects to the elders, laws, customs and creation spirits, and recognise that these lands have always been places of teaching, research and learning. QUT acknowledges the important role that Aboriginal and Torres Strait Islander people play within the QUT community. And I acknowledge also the people, the First Nations owners of the lands on which we all stand as we come together in this virtual meeting. So I want to just reflect on the meeting that we had, the workshop that we had last time. These are the insights where we compared, we talked about from different university perspectives, the different approaches and reflections on the report for the data intensive research from the Australian Academy of Science, and the kinds of comparisons that were made from two universities. We have the University of New South Wales and Monash, and the reflections that were made that you can see there about the different kinds of thinking about data science. So we saw that there were the reflections about this, the emergence of data science in terms of data science degrees, the market forces, the push from the students and the pull from government and industry, and the strong relationships between schools that sort of make this move to a more comprehensive view of data science possible. At Monash then, and I think across many of the other universities, different schools are offering different data science degrees, and even within the same university there can be multiple data science degrees that are being offered. And then there's also this opportunity, as we've said, about co-teaching between different disciplines. And so the Monash Data Futures Institute saw its role as fostering collaborations between the disciplines, and that was really something that's been borne out by many of our centres for data science in this consortium of the Australian Data Science Network. Many of the centres seeing their role as sort of bringing together these different disciplines. So today we want to focus on this recommendation about data science being recognised as a discipline and a field of research in its own right. This is one of the recommendations from the Data Intensive Research Report put out by the Academy of Science. And the recommendation states in particular that Australian universities should recognise data science as an academic discipline and review their organisational structure for data science so as to enable a cohesive data science discipline while encouraging collaboration within the institution and externally. And the reason that we've brought together this panel today is to talk about this from different perspectives. So we have Sally Cripps from Data 61 and CSIRO going to talk about this idea of data science as a discipline from the CSIRO perspective and her own perspective as a statistician. We have Kate Devitt from the Trusted Autonomous Systems, talking about it from a broader perspective as an employer and as a collaborator with universities around data science and how this is perceived. We also have Troy Farrell, who's Dean of Science here at QUT, talking about this from the university perspective and also from his own perspective as a mathematician. So thank you very much, Sally, Kate and Troy, for joining us in this panel session. What we want to do is to give each of you about 5 minutes, 5 to 7 minutes, just to reflect on this, this aspect of this report and indeed any other aspects of the report that you'd like to comment on. And then we'll come together for some questions at the end and some general discussion. So we'll start with Sally, we'll move to Kate, and then we'll finish with Troy. Is that okay with the three of you in that order?
Yes, okay, I think, yeah, yes, that would be fine. So I'll just, Kerrie, can I share my screen? Is that okay?
You can.
Just to give my thoughts about this. So hang on, wait a minute. Let me just see how I do that. Share screen. So firstly, let me thank you, Kerrie, for inviting me here today. That's a really timely thing for me to be doing because as you said, I'm a statistician. I used to be until about a year ago at Sydney University in the Maths and Stats School, and I led an ARC-ITTC in data analytics for resources and environments. And about 11 months ago, I took this position at Data61 as the research director of their analytics and decision sciences. And what I've been doing over the last year is sort of reformulating what Data61 strategy is, and in particular, what does it actually mean to be a data scientist? What are the aspects of that? And that's something that I've been trying to build into our program. And I think that the issue around, data science as a discipline is something that we most definitely, I think that's a path that we need to go down. But I think it is also, it's very clear to me, particularly after moving from the university, just how broad that area is. And so we need to be careful when we think about what it is. Do we want to go the way of the UK, for example, and have it where you actually get, where they're now looking at getting registered for different types of degrees, or qualifications. So, a data engineer versus a data scientist, and all these complexities come into it. And when I think about them, I'm just going to put up a few things, and hopefully that will show just how broad the whole area is. So I've been, as we know, it's data science is one word for it. There are many aspects to it. Machine learning and artificial intelligence are other words. Particularly, I'm a Bayesian statistician, and I've learned, if you want to get grants, you're better off calling yourself an explainable AI specialist than a Bayesian statistician. So getting some common ground as to what these things are. I'm just going to see if I can maybe flick through. So when I've been thinking about, so what does it mean to be a data scientist, and how might we actually think about it as a discipline? For me, it's a process of, a process of discovery, really. And I think about it from a problem-solving point of view. It's about learning from data, and that's effectively what I think of it. And when I think of it, what does that mean to learn from data, and what we do with that learning? And this is a slide from what I'm delivering for our strategic plan as a sort of a broad brush overview of how I view data science, which is, firstly, I've broken it down into data discovery delivery, because it sort of sounds nice when you've got a D for each word, you call it D cubed or whatever you want to call it. But when we think of it like that, it just brings out a lot of the complexity, because for the data, there's the issue of integration of, I've got them there, non-traditional, small, disparate data sets. There's a whole new bunch of techniques about adaptive sampling, which I'm really excited about. How do we collect the right data, not just necessarily use what data was collected for a totally different purpose? How do we do visualizations? What about privacy and ethics? All of those just come into data. So actually thinking about how we manage and curate data, that's one aspect of it. And then once we've got that data, for me, it's a process of what do we do with it? What are we discovering? So that's the discovery process. So we've got, obviously huge amounts of computationally efficient methods that we've got to come up with. Uncertainty, that's UQ is uncertainty quantified models. And I'm pleased to see that Troy is an applied mathematician, because one of the big areas now going forward is how do you actually start to view these mathematical sort of physical models as data or information, and include them with actual observational data. So viewing data as one form of information, and there are many other forms of it, and how do you do that? And then obviously we want to be able to do robust inference at scale. And lastly, and this last bit has been the bit that's really been very relevant. It's been new to me, because that's sort of where we stop it, or where I stopped at university. The full stop was the discovery. And since going to Data61, I've come across, I have now teams of super talented, wonderful people, and their job is delivery, and they do it really well. And it is actually a science in and of itself. How do you do this? So scalable and adoptable platforms, how can we actually take what we know, for example, about the natural environment, predicting bushfires, and put it out on a platform that's actually usable and deployable in real time for the community to use it? How do we engage with industry and government, as well as the community? And that whole area of translation, or that delivery of it, is something that I'm really excited about, and learning about new ways, new actual, and there's a whole set of technologies that go into that. So I think that's all I want to say, because I know I've only got a short period of time. But basically, data science for me is about how do you use data to deliver robust and risk-adjusted decisions in almost every field of life. I think it's something that we most definitely need to have a take on as a discipline. But I think we've got to be very careful and make sure we include all the players in it, because it is so broad that it actually requires a lot of thinking about how we would actually define it. Because once you start to define something, there's always people who are in and out. So that would be my comment, and I'll leave it there and I'll stop sharing my screen. Thank you.
Okay, thanks very much, Sally. That's really insightful. Okay, Kate, would you like to go next?
Hi, everyone. Thanks, Sally, for that great introduction. It's a lot of fantastic work at Data 61 and a lot of hoary problems to solve. So I guess my background, apart from working at Trusted Autonomous Systems, is also in the philosophy of science, philosophy of statistics and the psychology of statistics. And so I guess I wanted to approach this also as someone who was a big part of the cognitive science movement of the 90s and watched that all fall apart when the funding and the trend fell out of that area. So I think there's like a warning kind of story sort of embedded in my journey as well there a little bit. So as a philosopher, I have to start at the beginning. All right, data science as a discipline. All right, well, what is a science such that this would be a science? There's two aspects to try and figure out what data science is. One is a sort of theoretical question, and the other is a practical question. So the theoretical question is, well, whatever makes a science, sort of what properties does data science have that ensures that it is included in that set? So that demarcation problem usually means some people are in, or some kinds of methodologies are in and some methodologies are out, and that you need to satisfy those that judge the scientificness in some form of reliable and robust way. Why is that important? Well, because it has practical manifestations, practical outcomes. If you slice up data science in the wrong way, then it may affect its influence and impact. So because practically you want decision guidance in public and private life, and you want trustworthiness, and you want data scientists to be trusted experts. And you want the role of the university as knowledge producing and measured to be retained, if not enhanced. And it's going to have impact on climate policy, environmental policies, healthcare, expert testimony, science education, and journalism. So where you draw those lines could have significant impacts on how trustworthy the students are and the lecturers are and so forth, and how the broader community views data science. So I think that's sort of a background thing to think about. And it's important to realize that, so the philosophers who've been trying to figure this out for thousands of years, all the way back to Aristotle in the posterior analytics, is trying to figure out what makes science versus non-science, and trying to figure out why divination shouldn't be included. The sort of 20th century outcome here is there's no necessary and sufficient conditions to define a science, but discipline-specific criteria do need to be supplied. And in the end, it's at how do we determine which beliefs are epistemically warranted? So that's the kind of underlying idea with science. So this science is a fact-finding practices. Well, of course, if data science is a singular science, but it's covering all of data, that's problematic because you're trying to boil the ocean. I mean, just looking at Sally's slide there, she's sort of in charge of everything, right? It's covering it all. It's everything. And that boiling the ocean problem is a significant challenge because you don't want to not include things that are relevant to the belief forming practices. But you want to be known for being a thing. And what is that thing that you are known for? Otherwise, you've got a marketing issue,
yes,
as well as potentially a theoretically ungrounded discipline, right? So think about other fact-finding practices to just try and individuate between data science and other things that are similarly, you could apply those terms. So for example, journalism is fact-finding, criminal investigations, the methods used by mechanics to search for the defect in a malfunctioning machine. Fact-finding practices are prevalent in Indigenous societies in terms of traditional agricultural experimentation and tracking animal prey and so forth. Astrology and many different types of methods to try and uncover, facts about the world. So the demarcation of science is a special case of the delimitation of accurate fact-finding practices. So how do you know who's in and who's out? And I think if you think about the kind of data that is dominant in data science, it tells you something about its origins, but whether it tells you about its normative framework is unclear to me at this moment. So there's obviously been a movement of applied maths and statistics and so forth to formulate, and machine learning to formulate people into these data science compartments. But of course, the societal problems that data scientists are asked to solve might require a sort of thinking back out to qualitative data. Are you being scientists about qualitative data? Are you supposing that science has to produce one objective truth? Of course, as we know in statistics, its most famous line is lies, lies, and damn statistics. So how subjective, interpretable, pluralistic, and incomplete are the outputs of data science? Does it place itself in the same category as sort of pure maths and physics and these, chemistry, where there's clear boundaries between objects and processes? Does it allow for subjectivities? Does it become more aligned or potentially sympathetic to postmodernist practices or the humanities, which might allow for a diversity of interpretation around sort of the underlying reality, and everyone's touching the elephant in a different way and feeling different parts of the elephant. So that's a question of the epistemic commitment of data science. So as I suggested at the very start, I think that data science may in fact be a transdisciplinary science in the way that I think cognitive science wanted to be, and in some cases has been successful. Now, cognitive science was originally comprised of 6 different disciplines: philosophy, computer science, psychology, anthropology, neuroscience, and did I mention anthropology? I probably missed one. But the point is they were really different to each other. Oh, philosophy. So they're really different. They had humanities, sciences. They tried to have formalism and rigor and logic, but they tried to include anthropology to have a more subjective perspective. I think it was a pretty ambitious program in cognitive science to acknowledge the human and the subjective, but to try and provide methods that were robust and science-like, that they comported with the science aspect. The problem for me in cognitive science was we didn't have a building. So when I came to Queensland, University of Queensland in 2006, it was at the end of the fashion of cognitive science. And the only evidence of cognitive science that ever existed at UQ were these subjects that I actually lectured in: COGS 1000, COGS 2000, COGS 3000. And the whisper in the lurching background of the university that there was once this fabled time. So with now, of course, everybody's jumped onto artificial intelligence and data science. So don't worry, we're thriving. We're just thriving under this new, sexy, attractive places like institutes and so forth. But the institute culture and world is very fleeting. So the last thing I wanted to say is the politics of science is really important for data science. So there's all the underlying metaphysics and epistemology, but then there's the actual marketing and promotion of what you're doing, and they're trying to enable there to be pathways for students all the way through to promising careers. So I think probably data science is transdisciplinary and grounded in foundational disciplines like statistics, computer science, applied maths. But what's missing? Of course, I would say philosophy of science, epistemology, including Indigenous epistemologies. But I think broader research methods and ways of finding data and ways of aggregating it would be healthy, but dangerous, because it might mean you're boiling the ocean. That's enough for me. Thank you.
Okay, that was a lot to think about. So thank you very much. It's really interesting to see the parallels that you drew with cognitive science, and I'm really looking forward to the discussion on that after we finish. But before we start the discussion, we have one more panel member that we'd like to hear from, and that's Troy Farrell. So over to you, Troy.
Thanks very much, Kerrie. So I've prepared a couple of slides, so I'll share my screen in just a second. But as has been alluded to, I come to this with a couple of lenses, I suppose. So I'm an applied mathematician. I have about 20 years of experience as a teaching and research academic in a school of mathematics. And so my background is in algebra and calculus and differential equations and asymptotic methods. And my research is really around industrially relevant porous materials, multi-scale porous materials. That's where I've done my work there. Since about 2015, my primary roles have been in university leadership roles in various guises, either as a head of school, as a deputy dean, or as an executive dean. So, and I've always, in those roles, been in faculties that have in them the mathematical sciences, maths and stats, the computer sciences, information technologies, as well as the natural sciences, and sometimes even been in faculties that had engineering in there as well. So I guess I start by saying that I don't consider myself as a data scientist, but after Sally's introduction, I might start doing that. I'm not a statistician and I'm not a computer scientist, but I work with those people on a daily basis, and they're in fact some of my favorite people on the planet. So I'll start with that. If I just now just share the screen, I hope this works. Is that something that, can people see that? Forgive me if I'm not looking at the camera, I'm just looking at multiple screens here. What I did in looking and thinking about the question that Kerrie and Tim had posed for me to think about was, I had a look at the Australian Academy of Science report, which was a report late last year. And I can, to me, this is the kind of summary of what is contained around the presentation of data science being a standalone discipline in that report. So the report, presents data science as a discipline of its own accord, and it argues that data science already has many of the hallmarks of established disciplines, especially disciplines that have emerged from the amalgam or the convergence of several other disciplines. And that, in fact, I think if data science is a discipline, and I do think it is, then I think it has emerged from the amalgam of other disciplines, notwithstanding the sophisticated presentation that Kate just gave on what disciplines are in and what disciplines are out, right? I think that's a good question. So the report, when you get to university structures, I suppose, it kind of, some lines in there that really took my attention. It notes that data science at universities is ambiguous within traditional academic frameworks. More broadly, it says that there's a lack of data, rather ironically, about the quantity and quality of data science in Australia. So, and then it moves on to providing recommendations around 5 critical actions, and I've listed those critical actions there. And I'll come back to them when I finally get to my view on that. So, but before I do that, I just wanted to provide some kind of overview of what data science looks like where I work, and that's in the Faculty of Science at QUT. And notwithstanding the fact that in the virtual room today, I've got QUT colleagues who are well and truly living this. So data science at QUT, when you talk about discipline, I think it's actually quite important to talk about learning and teaching as well as research, because they have to be hallmarks of what determines a discipline, certainly at a university. And so if you look at data science, and I'm just using QUT as a surrogate here, I imagine that folks from other universities will see this and recognise this in their own institutions. We now have named qualifications in data science. We have postgraduate qualifications, a master's and a graduate certificate in data analytics. We have a Bachelor of Data Science degree now as an undergraduate qualification, and that connects with various double degrees across the university. In terms of professional and corporate education, we have just brought on something called a graduate certificate in IT practice, with, if you like, a major or a study area in data analytics, and that's how it'll be marketed. And then across the faculty, there are various other kind of fee-for-service activities that exist around the delivery of data science, if you like, for kind of corporate markets. Below that dotted line there, you can see a bunch of courses that, because of the nature of data science and how the above the line courses have been developed, they also contain elements of what you would identify as data science. So you can see there's a master's there in digital communication, but also qualifications in IT and in mathematics, particularly when we talk about those qualifications majoring in statistics and operations research. You would see elements in those qualifications that form the data science qualifications here at QUT, okay? All right. What, you know, like most universities, and a bit like what Kate and Sally have already alluded to, you know, if you're not on board the data train, then get on board, because certainly we've found that these have resonance in the marketplace, right? These are qualifications that students want to do. They think of them as future-focused qualifications. And that resonates very strongly. The lines that I'm showing you there, the graph, just as I've just been in this morning and pulled some enrolments out of our postgraduate data science and undergraduate data science courses. I'm not so worried about the numbers there, but what I look at as a dean of a faculty that provides these courses is the slope of those lines. And relatively speaking, the slope is high, right? The gradient is high. So students are really taking these up. And we only started our undergraduate course in 2021, so it's only been running for a year. We're seeing good student growth. We're seeing very good anecdotal evidence, especially from industry partners and students, around the alignment of our graduates with industry needs. So that's also very pleasing. I think the thing that I'll say on this slide and the next and the last slide is that there's a real confluence of data science. So in the Faculty of Science, the degree programs that are presented across three schools in the faculty. So they identify explicitly data science, but they contain academic staff, or they're delivered by academic staff in the schools of computer science, information systems, and mathematics. Okay. If I move to research, and I won't spend long on research because I'm standing virtually in a room with the director of the Centre for Data Science, and so I'm sure you're quite aware of that centre here at QUT. But really, data science research at QUT is characterised by a university level centre. Kerrie Mengersen is the director of that centre, and it's the Centre for Data Science. And if you, again, you know, to Kate and to Sally's previous points, if you have a look at that centre and how it's constructed, how it's organised, it is a transdisciplinary centre. It's meant to be a transdisciplinary centre. That's the whole idea of it. And you can see that in the leadership team. The leadership team is representative of multiple disciplines. You know, I would say that most heavily around stats, operations research, and mathematics. Computer science, information systems, business, and engineering are all represented in terms of the leadership team of that university, of the CDS. And, you know, the whole idea of the CDS, like other university level research centres at QUT, is that it cuts across those vertical silos. So if you think of those silos as being faculties of schools or schools within faculties, you know, different coloured silos there, columns, if you like, representing different faculties with different schools, then the CDS is, the whole remit of the CDS is to connect across those silos as a horizontal connector. And it's a higher degree connection than just a simple matrix structure, because by connecting, for example, with academics in School B, and then academics in School B connecting with another university centre, say in digital media, for example, then you've got connections between the two horizontal components of that matrix as well. Now, this is my terrible picture on the left-hand side of the slide. Kerrie's beautiful picture is on the right-hand side of the slide, or somebody within the Centre for Data Science gave me this picture. And again, it's trying to say the same thing. As the data science, the centre is a hub, and it connects with various faculties and then across into various centres and domains and schools across the university. The programs and the domains I've listed on the bottom there, and again, especially the domains, the programs are more kind of programmatic research focused, and the domains you can see are very applied, and they cut across many disciplines. Okay, so what do I think? So you're looking at the recommendations that are given in that report. I'm really largely very supportive of those recommendations. And, you know, I've listed a number of those. You know, the idea that we have a clearer taxonomy at 4 code and 6 code FOR codes for data science, I think that's an absolute no-brainer, even though we understand that in transdisciplinary 4 codes, it becomes a bowl of spaghetti because the connections between disciplines are non-linear, right? And so how do you choose that taxonomy? But I think it could be cleaned up, even given the most recent version of that. And the report suggests, you know, a taxonomy around 4 code and 6-digit codes, and I think that's reasonable. When in doing that alone, I think that's going to help facilitate the collation of data about quality and quantity. As will a suggestion in the report about the mapping at a national level of our data science capabilities. I think that again is also a very valuable experience or worthwhile experience. And then it talks about various nationally initiatives like an Australian Data Science Network, and everybody in the Australian Data Science Network should be congratulated for leading the way. I think a national level connected conversation about what is data science and what are we doing and what are our capabilities, as well as support on the ground through things like COEs or professional societies, and the kind of connections and support that needs to go into those entities. I actually think that those are that has to happen. I will say that where people will get nervous in this conversation is, I don't want to use the term turf wars, but it's always, I'm a big fan of growing the pie as opposed to slicing the pie, keeping the pie the same size and slicing it ever more thinly. So I think that it's really important that there's connection and coordination with various entities that already exist around the types of disciplines that you would expect to see front and center of data science. And that's all I note there. Importantly, I absolutely, addressing gender imbalance, the report talks about that, addressing gender imbalance. I believe that is vitally important for all STEM disciplines, including data science, and it should be a national priority. This is my last slide, Kerrie, and I know it's the $64 million question, and it's the one that you started with, and that's the recommendation that says universities should do something about their structures in order to support this. As a university, as a dean of a faculty, it would be, I should say something about this, I guess. I predicate this these are my own thoughts. They're not necessarily the thoughts of QUT, but I'm using my lived experience to bring my view on this. Dedicated data science research structures are fait accompli. They are no-brainers. The activities that we're seeing across all of our institutions, like Centre for Data Science, like the work that's being done in Data 61, of course, we should be elevating data science in that conversation. And there should be clearly identified data science kind of structures in that way. So do I think that all that will have schools or faculties of data science? That's a question. I've had the responsibility in the past of needing to develop new schools within new faculties. That is a heavy responsibility. And in the past, the way that I've done that is with a team of people and applying a set of basic principles around what I think a school is within a faculty. There are other people on this call that have also been involved in that process in the past. So what's my, so I reflected on that and the report, and I really think that, the question of whether we'll see standalone schools of data science or standalone faculties of data science is really going to be a practical one. It's going to depend on the breadth and depth of academic capacity. It's going to depend on the ability to be financially stable and sustainable in those initiatives. And we must recognise that the interconnections and the interdependencies between data science and the other disciplines, as Kate has so eloquently already put it, right? So I don't think you can ignore those. In a faculty, in a STEM-based faculty, those interconnections are going to occur across maths, stats, and IT, okay? So my guess is that organisations actually may not be able to sustain all of these at an individual school level, right? So, rather than create a winners and losers kind of a discussion, I think that in the long run, given the forward focus of data science and the unquestionable, to me, that it's unquestionable that it will be part of our national conversation and what we need to be good at, if you like, and what our graduates need to be good at going forward, we might see clustered outcomes, around maths, stats, and IT. But importantly, perhaps those clustered outcomes then begin to explicitly recognise data science as something that's really important for us. So that's all I wanted to say. I'm sorry if that went over time, Kerrie.
Oh, thank you, Troy. That was excellent. There's some really clear thinking there and some really important details for us for this conversation. I'd like to push a little bit on that because you talked to the point of having like schools or faculties around data science. And I'd like to hear from other people on this call, just very briefly. Do you have any comments about that? Do you see schools and faculties forming in data science as opposed to what Troy was saying also about having these sorts of groups in groupings that sort of recognise data science within the current frameworks? Does anybody on the call have some thoughts around that?
Go ahead, Marika.
Well, I was just going to say, I feel that really needs to be driven by senior management at university. So I feel impressed by your presentation, Troy, and because obviously at QUT you have buy-in from a lot of the different schools and different disciplines. And I feel that nationally, if data science is to get its own schools and faculties, it has to be driven by that. And I don't think that's where we are at UOW. So I'd be interested in hearing whether other people feel that nationally there is a commitment to those data science schools and faculties.
Thanks, Marika. Alberto.
I would. There we go. I'm there. Oh yes. I was just going to say, just to a point. I think Marika has a bit of point from my point of view. It has to be driven by us, but directed, like encouraged, nurtured by the people in power, right? So the driving itself has to be by us, the data science, statisticians, computer science, etc. But it has to come in the acceptance from above. My experience has been that there is support for creating the networks, like in our case, an initiative, a group, but I haven't seen it like, okay, we'll do the school of data science. I guess in a way trying not to be divisive and cannibalize on the other, right? So it's better to say CS, computer science, stats, math, come work together rather than create a new school.
Yeah, okay, thank you. Sally and Kate, from an external perspective, and I mean, I know that both of you have been internal as well as external within the university and outside, but from an external perspective, how important is it, do you see, to have like this sort of discipline perspective, or in fact even moving to having a sort of a school or faculty, which is the next step, I guess. So to you, Kate, first.
Yeah, I think it's immaterial in my Cooperative Research Centre perspective, which is to say we are a problem-based organisation and we seek experts that have the skills and the knowledge to help contribute to particularly industry-led projects to solve wicked problems. And that's where the transdisciplinarity is really useful. What's good about that is it means more inclusive, and we're very plastic. We don't uphold any of the silos of universities, which is one of the things I like about it. We don't care about 4 codes. We don't really care actually if anyone publishes in an top tier journal or not. It's actually about whether they can be a part of a team, do research as part of a team to solve a problem, to get something that actually has an impact for Australian sovereign capability. So we're very driven by the application of good research, very high quality research, but done so to solve a specific problem. And there is a tension constantly between the KPIs of universities, which really require young academics to focus on a silo, on a 4 code. If they don't do that, they're not going to get a DECRA and they're not going to swing to the whole AIC grant structure is really to try and prevent people from solving real world problems in complex ways, because you have to be on a singular journey. And that is a troublesome aspect of the research funding situation in Australia. So from the perspective of, can we solve Australia's research-based challenges with bushfires and climate change, do we need a discipline or do we need a 4 code? No, but for those who are struggling to maintain their careers and their job stability and to not be going, tiny grant to tiny grant, it could be really important for data science and data scientists to have that security. And if that's helpful to the data science community, then it's not a problem from our end, if that helps.
Okay, that's great. Thanks, Kate. Over to you, Sally. And I'm curious to how is data science discipline seen from your perspective? And also, how do people in Data 61 sort of see themselves, or how does data science sort of sit as a term or as a sort of discipline within Data 61, bringing the different groups together? You're almost like a microcosm of the university system or of the data science system anyway, aren't you?
Yeah, so basically the research program that I lead is the data science program. There are 2 other research programs about software engineering, which sit in Data 61, and another one about cyber physical systems. And the data science part, which is the analytics and all the stuff that I talked about earlier, that's what I'm in charge of. And it's actually being in Data 61 that's made me I've come to the belief now that actually, yes, I do think that it will be its own discipline, but I do not think it will be in science. I think what we're seeing here is the birth of an engineering discipline in much the same way that we saw the birth of chemical engineering, back in the 1930s. It went from being people solving problems in a sort of a more of a cottage industry base to somehow then saying, well, hang on a minute, and how do we do this at scale? And that's the perspective since I've come to Data 61 that I've come to realize. So I think the reason I think it will be its own engineering faculty, or not engineering faculty, but school moving forward, is because industry will demand that there is those skills. We will want to start doing this at scale. We will want to start digitalizing, having automated decisions, learning from data will become a normal part of any company's process. And that will require an integrated set of skills in the same way that chemical engineering is a mishmash of chemistry, physics, and a whole range of things, but they come together because they come together in order to deliver something that industry really, really needs. And so although I'm a mathematician and I belong in as faculty of science, and I think that, but then I do see that is where it's going, I think, and that's actually quite exciting. I think it is a birth of a new discipline. I think the problem with data science, and certainly from my own perspective, was you know, we see the birth of new sciences all the time. I mean, you know, so if we wanted to think about science as a big pie, you know, how we currently will break it up is just one way of dividing up that pie, you know, physics and chemistry. And we've seen that pie being divided up many ways to accommodate effectively market needs. So biochemistry, for example, is a combination of biology and chemistry, and that's now its own science. And I think that what's been a bit tricky for data science is that typically it straddles two faculties, and that becomes a lot harder than if it was just in one. But that's where and so I think it's quite exciting to think of it coming together. I think it will come together. I think effectively it will live in engineering, because that's where I think that the industry will drive it, and the jobs effectively will be. So we're seeing a lot of jobs in this space. And I think that is what ultimately makes universities decide to divide up the pie in a certain way. These are just arbitrary things, how we divide up the pie. Yeah, divide up the pie. Yeah.
Yeah, thanks, Sally. And I mean, I guess there's business as well. Business has a strong data science element as well, and sort of an ownership of that as a discipline, health as well. So I guess it depends on the lens. I'm going to ask each of you, if you'd like to ask each of the other panel members a question. So hearing the different talks, coming from your different perspectives. Troy, would you like to ask Sally or Kate a question? I'm throwing this. I'm just telling everybody they haven't been prompted about this, so this is completely off the cuff.
As you'll
so
see.
I'm just putting me. I mean, not only have they had to do homework on their own talks, but now that I'm actually asking them to do my job as well. But Troy,
look, it's not so much a question. I think I kind of observe or make the observation that I think largely the three panelists are you know, on a very similar page. You know, Sally spoke to us about that breadth of data science and what's now, you know, being considered as part of that. And I think in a way, Kate then was talking about how difficult it is often with those kinds of disciplines. She gave the example of cognitive science, how difficult it is with those kinds of disciplines to actually get structures in place that make sense. And I totally agree that, and that's why I think that the idea that you have a ubiquitous structure across the country, I doubt that that's the case. It will depend on the kinds of emphases I think that you have in various organisations and institutions and universities as to how that clustering might actually occur, is my guess. I guess, you know, I suppose that what we're saying as a panel, and I know this is not a question, and forgive me for it being a diatribe, Kerrie, I suppose that what we're saying is I guess we agree that it's a, you know, it is a thing, it is a discipline. It's not something, it's something that should be curated, it should be supported. I don't think it's going to be a fad, but that's what you would expect a mathematician to say. You know, but I, you know, so from that perspective, I think we're kind of all saying that it should be supported and encouraged and thought of as a discipline. Was there any question in that?
Thanks, Troy. No, that's perfect. Okay. Sally.
Okay, so
question or comment?
Yeah, I have a question. Okay, so I'll get one to Troy and then one to Kate. So Troy,
remembering we've got about 2 minutes.
Oh, then I'll only do one to Troy, which is so thinking about what you've just said, which is the whole range of or the, you know, breadth of possible versions of data science. Do you think that there's value in, so as they're doing in the UK, is having, they're defining or having a, you know, what a different, you know, so to say you have some, you know, a board or like in accounting where you get accredited. Yeah. So you get accredited for a data science versus a data engineer. So do you see that as a valuable or a worthwhile thing to sort of pursue going forward from a university perspective?
So I thank you, Sally. I think that's an interesting question, and it's not. So as a mathematician, and I'm sure the statisticians have been in conversations like this in the past, there have been these questions about the value of professional accreditation for disciplines like mathematics and statistics in the past. We see those professional accreditations, of course, in engineering. It's part of a requirement to be able to practice. We see that also being useful in IT through ACS accreditation. And actually, we have some evidence that the ACS accreditation, for example, encourages students to think about the quality of an undergraduate offering in IT. So I would, do I think it's important? I can't quite see the case for a professional accreditation in data science yet, but I would be asking, asking industry and saying, would it be valuable to you that there's some kind of set of criteria that's placed across each one of the graduates above and beyond the graduate attributes that universities have to be imparting as part of accredited courses in the first place? So that's what I would do.
Okay, thanks. Kate, last word to you. Apart from that very alarming black thing that came up across your screen. And
cattail.
Cat
a bit of a cattail, frustrated cattail seeking hugs. So the last minute, I guess it's just a provocation, perhaps, with Sally, with your, but to Troy as well. I think there's a provocation by the Turing Institute in terms of, okay, we've got data science, but what about data humanities? And so I'm interested because there is a dominance, and you worry about women coming into STEM and you worry about this pipeline, but if your three disciplines are these really crunchy boy clubs, is there a loss for the potential of the impact of the discipline by having only at that core those very male-focused disciplines?
Okay, I'm going to leave that because we are at time, and I'm going to leave that as the hanging question that people might reflect on. And I know, Sally, you've got something on the tip of your tongue. Do you want to say?
No, I do, and I think it's an excellent question, and it's something that I'm very passionate about. So, but for another time.
Okay, perfect. All right. Well, just I want to thank everybody very much for their comments. And especially I'm just going to get this up. Our three panel members, you've been fantastic today. Thank you very much. I just want to thank you for your time and for your comments. I also want to note that we have the next part in this series is going to be around the Aladdin project reports. And so these are sort of building on, or not building on, but complementary to the Academy of Science report. So we're going to talk about this on the 12th of August. Please join us for that. And also just reminding people that we have an Australian Data Science Network conference, our first ADSN conference that will be held in November here at QUT. So on that note, then I'll bring this session to a close. Thank you again to all the panel members, and thank you again to the people who participated in the call. Okay, bye for now.
Thank you. Thank you, everybody.
Thanks, everyone. Thanks, Kerrie.